Welcome to my YouTube channel. Today, I'll be discussing on how to find the factorial of a number in Python using recursion. What you're seeing on your screen right now is just a fun way of representing what recursion is. Recursion is not that difficult to understand, as I'll explain this to you in a few moments. So, we have two problems in our hand right now. First is a factorial and the second is a recursion, that is, we have to solve this using recursion. Factorial of a number, as its definition, is the product that we get when we multiply this number by all the preceding natural numbers. That is, factorial of 5 will be 5 into 4 into 3 into 2 into 1, which equals 120. So, as the definition holds, we can only find the factorial of non-negative integers, that is factorials of 0, 1, 2, 3 and so on, only they exist. At this point, I need to mention that factorial of 0 is 1 and this is an accepted convention, and please don't ask me why. Right then, the second problem that we have is that of recursion. So, what is recursion? Simply put, the property of a function when it calls itself is called recursion. You may have gotten dizzy at this moment. Don't worry, allow me to explain this in a more intuitive way. When we say a function is recursive in nature, it means that that function is calling itself or invoking itself. So, now the invoked function, by the very nature of recursion, will again invoke itself, right? So this will go on forever until we provide it with a termination condition. In a recursion function, such a termination condition is called a base case. So whenever a recursion function invokes itself, it must get one step closer towards its base case, where finally this recursion will stop. So whenever you use recursion, you must, and I can't stress this enough, you must always provide a correct base case. You must check it and provide it correctly. That's all the information you need to know about recursion right now. I know it might be mind-boggling and mind-numbing thing at first, but trust me, you have to take a leap of faith to properly understand recursion. Now I will explain recursion with respect to the factorial problem we have at hand right now. My advice would be not to see this problem as a factorial problem using recursion, but see it as understanding recursion using factorial problem, because we all know what factorial of a number is, right? So let's just jump right to it, shall we? We know that factorial of, let's say, 4 is 4 into 3 into 2 into 1, which equals 24, right? This means that factorial of 4 could also be written as 4 into 3 factorial, right? Because 3 factorial is equal to 3 into 2 into 1. That's why 4 factorial is equal to 4 into 3 factorial. Again, this 3 factorial could be expressed as 3 into 2 factorial, right? Because of the same reason as mentioned above. And 2 factorial could be expressed as 2 into 1 factorial. And in the end, we know that 1 factorial equals 1. Then we will return the value of 2 into 1 factorial, which is 2 into 1, which equals 2. Then we'll again return the value of 3 into 2 factorial, which is 3 into 2, which equals 6. Then we'll return the value of 4 into 3 factorial, which is 4 into 6, which equals 24. So the final output that has been returned is 24. So the thing to keep in our mind in recursion is, we unfold the tree by invoking the recursive function again and again until we reach the base case, and then we return the value of whatever operation we did. In this case it was multiplication, so we return the final output. Now the code will look something like this. We will define a function with the name factorial, which would take an integer as its argument. Note that this integer has to be 0 or greater than that. If the argument here in this case, which is n is 0, then we will return 1, because factorial of 0 is 1. Now we'll define our base case, which is if n equals 1, then return 1, else in every other case we return n multiplied by the factorial of the preceding number, which is n minus 1. Right? Fair enough? This will go on until we reach factorial of 1, in which case it will return 1. That's it. You're done now. It will look something like this in this Spider IDE. So here, this is the code that I've explained it just before moments ago, and this is the output console window. Alright, fair enough? Very well done. So, just to recap what just happened here, recursion is just a property of a function when it calls itself again and again until it is made to stop using a base case or a termination condition. So, if you've understood it, if you've liked the video, I would encourage you to subscribe to this YouTube channel for more such exciting contents. So next time, cheerio.